Hey everyone, good morning. What did we do in the last class? I guess we're done with hyperparameter theory, right? Okay, so that completes your regression and classification models. So I have discussed all the models, including theory as well as in implementation. So now it's a time to explore unsupervised learning. So let me share my screen. Okay, yes, tell me, what is unsupervised learning? So when it comes to a unsupervised learning, you know that it requires just what kind of data is required to it. So when we said supervised, we were expecting both input and output. When it comes to an unsupervised learning, we need just an input data, right? No labels. So for such data, I mean for such algorithms, usually we call it like a unsupervised learning. Yeah. So when I say unsupervised learning, basically it requires unlabeled data.
See, I'm getting full. So Wednesday, Monday, Tuesday, I'm getting.
When I say
I can get half of the month MON. I want to see.
So when I say unsupervised learning, it requires an unlabeled data. Unlabeled data in the sense it requires input data without a labels. So many a time when it comes to a real world, there will be a data without labels. So to handle such data sets, we have a concept called as unsupervised learning. So under unsupervised learning, so we use a concept called as a clustering. So when I say clustering, unsupervised learning uses a clustering concept. So uses clustering in the sense. So what it does, it tries to group all the data into different clusters based on similarity. So since there will be no labels, it's just like If you are teaching a child, showing each fruit and telling its name, it's like an apple, it's like an orange, it's like a grape, showing an image and telling the label. So child understand better in a better way, right? But the thing is, what if I give a basket full of fruits to a child and if I ask a child to group them into different groups? Even without a prior knowledge of those fruits, even child will be able to group them together based on a similarities like a shape, size, color. Based on all those factors, the child will be able to group them into a different clusters, right? So that is what is happening in a unsupervised learning. It just creates a different clusters. So based on our clusters, we understand like what's happening across the data. Okay, this is related to unsupervised learning. I hope you got it. The best example you can think of, market basket analysis. When I see market basket analysis, basically what happens, it just gives you the similar things will be kept together, right? If you see, look into the supermarket or e-commerce sites, the similar things will be grouped together so that it becomes easy for our customers to do a shopping. Same goes with mall customer segmentation. What if you want to segment or group customers together to understand what amount of people, what age people, or what kind of people are interested in what product, so that that helps a manager customize products in a better way. You can use Netflix recommendation or product recommendation on a Google. Netflix, based on your search history, based on the movies that you have watched, or the people with same interest as you, whatever movies they have watched, accordingly, it basically suggests you or recommend you the movies. So these are the movies watched by the most frequent people, or these are the products which are brought together by a multiple people, right? So that helps customers in analyzing or watching movies related to what they have watched or to purchase a products that what other people have purchased. So that's how unsupervised learning is basically used. Okay, I hope you got it. The one important algorithm that comes under unsupervised learning is basically the k-means. Any idea what a k-mean algorithm, what does k-means? What is k-mean? So when I say k-mean algorithm, it comes under unsupervised learning and is also called as a clustering algorithm. K-mean comes under unsupervised learning. It's also called as a clustering algorithm. Which groups or which clusters enter data into different groups. based on similarity. This is the definition of a k-mean. Hope it's clear. So what is similarity in this case? What is similarity? Similarity in the sense it's a nearest distance. Okay. So the k-mean algorithm is a distance-based algorithm, which basically uses our distance formulas to find the distance between the similar points. Unlike KNN, k-means is also called as distance-based algorithm, which uses distance formulas to find similar observations. Or I would say to find a similarity. You know already what are the distance formulas, the different distance formulas already have discussed when it comes to a KNN. What are the distance formulas that we used? We have two distance formulas. One is Manhattan. And then we have our Euclidean. Euclidean. So these are the distance formulas that we use in our k-mean algorithm. So now you know what is k in k-mean? K in k-mean in the sense it's a number of clusters. Number of clusters. Now let's understand like how k-mean algorithm is going to work. Any idea how k-mean works? So when I say k-mean, first step, it will plot data on a graph. Okay. So it just plots the data. Okay. So plot data. Second step, we have to define the number of clusters need to be created. So define k. Define k. I'll define k equals 3. So here k stands for number of clusters. K equals 3 in the sense. So create 3 clusters. Okay. So once it defines k equals 3, so what it will do? It randomly creates 3 clusters. Let's say this is one cluster. And let's say this is another cluster. Let's say this is third cluster. So this is how it creates 3 clusters, k equals 3. So what next? Then it will initialize centroids in each cluster. it will initialize centroids in each cluster. So now the question is like, what are centroids? Centroids are nothing but they are a cluster centers. Cluster centers, which are calculated by taking average of all the observations in a cluster. Okay. So when I say centroids, centroids are cluster centers created by taking average of all the observations in each cluster. Okay, so you have a 3 clusters now. So in each cluster, let's say it will take average of all these observations and it will create a cluster center here. Similarly for this, let's say it creates here. Similarly for this, let's say it creates here. That's how the cluster centers are created. Getting? Cluster centers are basically the centroids, which are calculated by taking average of all the observations in each cluster. What next? Understood so far? So what next? The next step is, now we have to find distance between centroid and all other observations. Now it will start finding distance between all other observations and a centroids like this. Similar way this. Okay. So once you find the distance, what should be the next step? So once you find the distance, now you have to assign points to the nearest cluster based on distance. That means whichever point is near to whichever centroid, so that point gets converted to that particular cluster. See what happens? All these observations are near to red centroid. Yes, yes. This is nearer. This is nearer. This is nearer. Yeah. And then coming to a blue. So don't you think this observation, this, all these are nearby? Coming to black centroid. All these observations are near to black centroid. So they get classified to the black centroid. So now you have to reform your clusters. So now the clusters will change, no? So now the clusters will be reformed based on this distance. I'll show how just a minute. Okay. See what happens now? See, all these observations will fall under a black thing. Okay, and this is one cluster. And then this is another cluster. So this is one time the process happened. Like this, the process has to repeat until you get a clearer clusters without overlapping. The process should repeat. Until we get a clearer clusters. So how it will repeat? Again, same thing. It takes average of all the observations. It will initialize the centroids, and then it will start finding distances. The closed observations get classified to that particular centroid. So like this, the process keeps repeating until we get a clearer clusters. That's how the k-mean algorithm is going to work. Hope you got it. Any questions you can ask. Here, understood. Now, important thing, what is the goal of k-mean? Like, what are we trying to achieve here? What is the goal of K-mean? What are we trying to achieve here? Goal of K-mean. How do we achieve? So when I say goal of K-mean, it is expecting two things. So we say it's a clearer clusters, or we got a proper clusters only if intercluster distance should be high. Intercluster distance should be high and intra-cluster distance should be low. You tell me what is intercluster distance, what is intra-cluster? What is intercluster distance? So intercluster distance in the sense, let's say for example, you have two clusters. Okay. So distance between observation and two clusters should be very high. That's a intercluster. The distance between observations in two clusters should be high. Okay. Coming to an intra-cluster. What is intra-cluster? So these are two different clusters, right? Obviously, distance should be high. Distance between observations in two different clusters, they are not similar. Observation in this cluster is different from observations in this cluster. That's the reason they have grouped separately, right? So obviously the distance should be high. Coming to this, intra-cluster distance should be low. So that means a distance within the cluster should be very less. That's what we are expecting. Okay. So the distance between observations within the cluster should be less because they're all similar observations, right? They're all similar things. Similar things will be put under one single group. So obviously the distances should be very less. Obviously the distances should be very less. These are the two different goals we have to achieve from K-mean algorithm. Got it? Now the question is how to evaluate your K-mean. How to evaluate K-mean and how do you see that it's a good model? So in order to evaluate a K-mean, we use a concept called as a Silhouette score. So it is kind of metric used to evaluate K-mean. And it uses a formula B minus A divided by max of A comma B. Okay. So A is intra-cluster, B is inter-cluster. So basically, Silhouette score will tell how clearer the clusters are. Range will be -1 to 1. It just tells like how clearer clusters are formed. So this is all related to K-mean algorithm. Any questions you can ask? If no questions, just take a break. And then I'll show you how to implement a K-mean algorithm. Take a break. You people are back. Let me upload data into your drive, so please do download it. And then let's do the implementation. I have uploaded a data mall customer.csv. Download this small customers.csv, open a new notebook, just upload data. Once done uploading, load our basic libraries and also load the dataset. Import libraries and load our data. You know, right? Already you have done so many projects. Import libraries, load data, and just let me know. Import NumPy as NP, import pandas as PD. So this is the data set that we have. Done importing, done loading data.
Yes, ma'am.
Perform our basic checks. Perform basic checks, check for missing values, duplicates. Print all the numerical columns. You have one categorical column which is gender, male or female. So clearly no missing values. And then check for duplicates. No duplicates. No missing values and no duplicates. Is it done?
Yes, ma'am.
Let's do an EDA to visualize the data. So this is a data set that we have, which shows some information like customer ID, gender, age, annual income, and a spending score. So clearly, customer ID is not required for this because it's just a unique representation of each customer. For building clustering, obviously gender matters, age matters, annual income matters, and spending score matters, so that we can cluster them into a different groups. First one, let's find the count of male and female. How do you find the count of male and female? So just finding count, visualize the count of male and female. Use a count plot and try to visualize it. PLC dot figure of fixed size equals 5,2. So we have maximum information related to female and bit less related to male. Hope it's clear. Next one. Find average spending score with male and female. Which graph should be used for this? Use a bar plot. So on an average, you can see the equal spending score between male and female. So find relationship between age and spending score. find relationship between age and annual income, and also find relationship between when it's a relationship, use a scatter plot. You scatter and try to plot it. So age should be capital A. You could see as age is less, the spending score is more. As age increases, people will have responsibility. People knows like how to spend. So you can see the spending score is always less with people whose age is above 40. 20 to 40 is the age wherein there are certain group of people who spend more. Not everyone, because there are few people who spend less as well. Relationship between age and annual income. So on an average, you can see here, people from 20 to 30, 20 to 40, annual income is high. Usually that's a phase. 25 to 40 is the phase wherein you get a good annual income. So let's say the age, the income will be higher as the age increases, obviously, the annual income will reduce. That's a fact happening in a market. And the next important thing, find the relationship between annual income and a spending score. So usually if annual income is high, the spending score will also be high, right? If annual income is less, spending score will be less. If annual income is high, the spending score is also high. You can see. It's like 50-50 result usually. There are certain amount of people who don't spend much even though their income is high. Some people, even though their income is less, they spend more. Understood? Hope it's done. So it should be the next process.
Bivariate analysis.
What did I do so far? Scatter bar, they're all bivariate itself, right? If you want, you can check the distributions, like how well data is spread out. You can check the distribution of age, annual income, spending score, like how well the data is spread out. So it's in his plot. X is going to be an age. Same we can try for annual income. So you can see according to those data, maximum information we have is somewhere between 20 to 50 age, and very less related to the old aged people. And coming to this, so annual income, maximum people have annual income somewhere between 20 to 80K dollar, and very few people have the very high income. Coming to the spending score, so maximum spending happening between somewhere like 40 to 80. That's a range. So this is how you visualize data with respect to different graphs. Let me know once you are done, then I'll proceed. Done with this? We need to apply, do we need to apply an encoding technique? If yes, on which column, which encoding technique I have to use? So we have gender column wherein we have a male and a female. You have to convert that to a numbers. So how do you do it? Just using one hot encoder,
Mapping.
you get a miss. Pass your data. columns equals gender. Data type should be integer. Next important thing, performance scaling. It's basically a distance-based formula. It's always good to perform a scaling whenever it's a distance-based formula because finding distances will be easy when all the values lie within a same scale. You can use either standard scalar or a min-max scalar, and you can try to perform a scaling. So in all the columns, you have to do it on age, annual income, as well as on a spending score. You know how to implement. So from sklearn.preprocessing, just import and scalar. What it equals standard scalar. Is it done so far? Any questions? Thank you. Thanks for joining.